Welcome to the AI Checkpoints. The buzz around AI agents are these autonomous systems that can actually plan, execute, and adapt all on their own. It's been absolutely electrifying. We've all heard the big promises. But the real challenge, getting them to work reliably, consistently, without needing constant babysitting in the messy, complex world of large organizations, that's really where the rubber meets the road. So our mission today is to do a deep dive into a really interesting new framework called routine. Think of it as maybe the ultimate playbook for these next-gen AI agents specifically designed to tackle those real-world enterprise problems. We're going to unpack exactly what routine is, why it's apparently so important, and how it helps turn these chaotic, multi-step tasks into, well, remarkably stable, accurate, and efficient AI workflows. All of this is based on some fascinating research. A paper titled Routine, a structural planning framework for LLM agent system in enterprise. Okay, so let's unpack this a bit. We've seen some incredible advancements, right? LLM-based agents like AutoGPT, AutoGen, they've shown amazing general skills.
Things like data analysis or messing with web interfaces. But the moment you try to put them into those specific, complicated business scenarios, they often just hit a wall. Why is that exactly?
Yeah, it's a great question. And what's really fascinating here is despite all their power, these common LLM models, they often lack the deep domain-specific process knowledge you absolutely need in a business setting. So this leads to kind of disorganized plans. They might miss crucial steps, especially things involving, say, permission checks, which you just cannot skip in a corporate environment. And overall, you just see really poor execution stability. The research points this out clearly. General models aren't really built for the nitty-gritty of enterprise operations.
Okay, stability, yeah.
And the plans themselves.
Right, it's not just missing tools. A huge issue is that the planning itself often lacks a standard, structured format. Imagine trying to build something complicated, like IKEA furniture, but without clear, step-by-step instructions. It's chaos. And that ambiguity means the agent's execution part really struggles to figure out the right tool calling instructions. So you get this frustrating mismatch between the plan and what actually happens. Right, so it's not just about the AI being smart in some general way. It's more about it having a clear, reliable playbook tailored for that specific job. This kind of reminds me of that second wave they talked about in agent development, where the focus shifted from just raw power to making them stable and reliable. Is that a fair link?
Oh, absolutely. That's spot on. If you connect this to the bigger picture, yeah, those earlier architectures, they suffered from something called step explosion. Basically, the agent trying to figure out every tiny little detail itself, it was messy. And it led to really inefficient context management, the model juggling way too much info, and these fragmented execution flows. So the whole plan then act idea emerged to bring some discipline, right? Make planning more rigorous, make agents more practical for the real world. Routine really builds on that foundation.
Okay, so this brings us right to routine. The paper proposes this framework as the solution. So how does it actually work? What's the magic?
Well, at its core, routine is a multi-step agent planning framework. It's built with a very clear, explicit structure. It gives precise instructions and allows for seamless parameter passing between different steps. Its main job is really to guide the agent's execution module through those complex multi-step tool calling tasks with super high stability. And that stability, that's the game changer for businesses.
Let's break that down. How does routine actually enhance the typical parts of an agent system?
Yeah.
Maybe starting with the planning module. This is where the agent figures out what to do, right? So what does a routine actually look like?
Okay, so a routine is essentially a sequence of really specific execution steps for subtasks. Each step is distinct, but they're often interconnected, And each step includes key info, a step number, a clear step name, a detailed step description, and crucially, the specific step tool that should be used for that step. You can also optionally add input and output descriptions, which helps add even more clarity, especially for complex stuff.
Okay, step name, description, tool. Makes sense. What about complicated workflows? Things aren't always linear.
That's a really neat part. Routine handles conditional logic pretty well. So if certain conditions are met, the plan can explicitly say, okay, now go to branch X1, step 1. It guides the model through those decision points, making sure it takes the right path based on what's actually happening instead of just guessing.
And making these routines. That sounds labor-intensive if you have hundreds of processes.
Right, you can't manually craft every single one. So the research outlines this really clever solution. An expert can provide just a simple, maybe even rough draft of a process. Then a powerful LLM like GPT-4o, using a specific prompt template they designed, can take that draft and automatically optimize it. It breaks the plan down into detailed substeps, maps them precisely to the tools you have available, and spits out a perfectly structured routine.
Whoa, okay. So it's like having an AI assistant that takes your rough notes and turns them into a perfect executable script for another AI.
Exactly. It's like an AI co-pilot for planning. That automated optimization, that saves a ton of time and effort. It's a game changer in itself.
Okay, very cool. Now let's talk about the execution module. If planning needs these big, powerful LLMs, why not just use one giant model for everything? Planning, execution, the whole deal.
Yeah, that's a really good question, and it gets right to the heart of making this stuff efficient for businesses. Planning often does need high computational power, complex reasoning, but the execution part, while it's absolutely critical, it involves a lot of context management and, frankly, kind of repetitive tool calls. Using a massive model like GPT-4 for every single little execution step is incredibly resource heavy. And maybe more importantly, it's slow. That just doesn't fly in a real enterprise environment. For execution, the main things you need are really precise multi-step tool calling and just accurately following instructions. You don't necessarily need super complex reasoning at that stage.
Ah, okay. So routine lets you use different tools for different parts of the job.
Precisely. Routine cleverly allows smaller, more specialized instruction-following models to handle the execution. These smaller models just follow the structured plan routine gives them and output the exact tool calling instructions needed. Simple as that. And there's another efficiency layer, the final response back to the user, the natural language part. That's not even generated by the execution model. Instead, they use a dedicated summarization tool for that last step. Make sure the output is concise, relevant. It's a smart separation of concerns.
So what this all boils down to is using the right tool for the right job. Big models for the heavy lifting and planning, smaller, faster models for the execution. That saves resources, makes it more practical, faster too.
Exactly. It makes AI deployment way more viable and efficient for businesses.
Got it. Okay, next up, the tool module. The execution module sends instructions to call tools. What's actually managing those tools and making sure they work right?
So the system in the paper uses something called MCP servers as the tool module. You can think of them as like a standardized gateway or an interface to all the available tools. This server doesn't just give access, it defines and manages the tools in a really structured way. Each tool is described uniformly its name, what kind of parameters it needs, any constraints on calling it, so the execution module. It just needs to retrieve the right function from this MCP toolset, following the routine's step-by-step guide, and then fill in the parameters precisely. The agent doesn't need to know the messy implementation details behind the tool, just what to call and what info to pass along.
That's brilliant. It's like having a perfectly organized, standardized workshop. The AI knows exactly which wrench to grab and how to use it without needing to know, like, the metallurgy of the wrench itself. Just grab wrench, turn bolt.
Exactly. Standardizes the whole process.
Okay, finally, the memory module. This seems critical. With all these steps, tool calls, parameters flying around, models can easily get overwhelmed by context, right? How does routine stop the AI from drowning in information?
Yeah, that's a huge challenge. How do you prevent context overload? How do you maintain accuracy when tasks get really long and complicated? The research introduces two clever forms of memory to handle this: procedure memory and variable memory.
Okay, procedure memory first, long term.
Right. Procedure memory is like the long-term storage. As you generate and optimize routines for different scenarios, you might end up with a whole collection, maybe dozens for different HR tasks, for instance. Now, loading all of those into the execution model's prompt every time, that would be super expensive in terms of tokens and just add a lot of noise. So you establish this procedure memory base. When a user asks something, the system retrieves only the most relevant routines. It does this using similarity calculations between the routine's description and the user's specific task. This makes sure the execution model gets exactly the plan it needs and nothing extra. Better cost, better accuracy.
Smart. And variable memory, short term.
Exactly. Variable memory is short term for the current task. In these multi-step processes, the execution history builds up. And sometimes the results coming back from a tool call can be really, really long, like a huge chunk of text. This puts serious pressure on the model's context window, increasing the chance of errors or just hitting limits. So when a tool returns a super long parameter, the system automatically stores it in this variable memory. The model then just works with a short key, like, very important .001, instead of the whole massive text block. Then, right before passing it to the next tool that needs it, the system swaps that key back out for the actual value. This massively reduces the context pressure, saves tokens, makes even smaller models more robust, and it's temporary resets for each new task.
Wow, that's incredibly clever. It's like giving the AI a smart scratch pad for its current job and a really well-indexed library for its overall procedures. It only pulls what it needs right when it needs it.
Precisely. Keeps things focused and efficient.
Okay, so we've got the structure of routine down. Now, the really crucial part. How well does this thing actually perform in the wild? The paper talked about testing it in an HR agent application. What did they actually find?
Yeah, the results they reported are pretty compelling, actually quite dramatic. Without routine guiding them, the baseline models, they performed pretty poorly. None of them got above 50% overall accuracy in this realistic HR agent scenario they set up. And get this, a staggering 85% of the errors they saw were tool selection issues. It just hammered home how much these models struggled to pick the right tool from the pool they had, which was over 25 options.
Wow, 85% tool errors. So what happened when they switched routine on?
The performance just jumped dramatically. GPT-4 accuracy, for instance, went from about 41% all the way up to an incredible 96.3%. And even Qwen 314B, which is a significantly smaller model, saw its accuracy rocket from around 32% up to 83.3%.
Whoa.
Yeah. It clearly shows routine really helps compensate for the planning weaknesses, even in smaller models. It lets them punch way above their weight in these specific complex tasks.
Those numbers are.
Yeah.
Yeah, they're mind-blowing. Routine isn't just a minor tweak. It sounds like a fundamental game changer for getting these agents to work reliably.
It really seems that way. And the analysis confirmed the main reason for that boost was the huge improvement in tool selection accuracy. It just shows that routine successfully breaks down the task into clear, actionable steps, pointing the models directly to the right tools. They noted fewer structural and parameter errors, too, but tool choice was the big one.
Okay, and they also looked at training models with routine, right? What did they learn there? How do you teach an AI to use this structure effectively?
Right. They explored two main training strategies. First was what they called common routine following fine-tuning. This worked really well at making models better executors when you gave them a routine. They got good at following the plan, but there is a trade-off. Their ability to plan autonomously without a routine, that actually went down. So it sort of reinforces them as excellent plan followers, which is definitely useful, but maybe not as independent planners.
Okay, interesting trade-off. What was the other strategy?
The second one was scenario-specific data distillation. This is where it gets really exciting for scaling this up. They used a bigger teacher model guided by routine to generate lots of training examples for specific scenarios. Then they trained smaller student models on that data. And the cool part, these smaller models showed significant accuracy improvements even when they weren't given an explicit routine during the test. For example, that smaller Qwen 314B model, it reached 95.5% accuracy this way, which is right up there with GPT-4's performance using routine directly.
Wow. So it's not just about giving the AI the map, the routine. It's also about training it to be a better navigator internally, embedding that procedural knowledge right into its core.
Exactly. That's a great way to put it. If you think big picture, it really shows that injecting this kind of procedural knowledge, both externally through prompts like routine and internally through model weights via training, that's a super effective strategy for getting maximum stability and capability for specific tasks.
That is really fascinating.
Oh.
Okay, and they also did these ablation studies, right? Where they took parts of routine away to see what broke. What did they find were the most critical ingredients?
Yeah, those ablation studies are super insightful. They basically picked routine apart piece by piece. One key finding was about explicit tool names. When they removed the specific tool name from the step description in the routine, accuracy dropped significantly, like 15% for most models.
Yeah.
Even the powerful GPT-4o benefited from having it spelled out. It just confirms that telling the AI exactly which tool to use is critical. It turns a hard reasoning problem into a much simpler execution task.
Makes sense. What else?
They also looked at the input-output parameter descriptions, those optional details about what a tool needs and returns. Adding those significantly helped the less capable models. It seemed to improve their understanding of the context and cut down errors. For the really high-performance models, the benefit was smaller, more incremental. So it suggests those descriptions are especially helpful for models that need a bit more hand-holding.
And what about AI versus humans creating the routines?
Right, they compared AI-optimized routines, starting from a simple draft, versus human-optimized ones. The research showed that the AI-optimized routines gave universal performance boosts. For some models, it closed a lot of the gap compared to the ones meticulously annotated by humans. So while having a human expert craft the perfect routine might still be the absolute gold standard for supercritical tasks, AI optimization is clearly an efficient and really viable path for most enterprise scenarios.
That's huge for scalability. Okay, one more. Memory. What about the number of routines you show the agent? Does more choice help or hurt?
Yeah, that raises a really important practical question. If your system has tons of routines stored, should the agent see all the potentially relevant ones? Surprisingly, for the high-performing models, giving them just one correct routine was the most effective approach. When they introduced even a few distractor routines, ones that weren't quite right for the task accuracy, actually dropped significantly at first. Although, interestingly, it sometimes recovered a bit if they added even more distractors. The hypothesis there was maybe the model switches gears and starts trying to select the best routine, kind of like it selects tools. But for smaller models, the performance swings were even bigger. It really highlights that you need super precise memory retrieval. Get the agent exactly the right plan and avoid confusing it with irrelevant options.
So it all comes back to precision, clarity, and really smart memory management. Getting the right routine into the agent's focus at the right time seems absolutely paramount.
Definitely, precision is key.
Okay, so looking ahead, what does all this mean for the future of AI agents in the enterprise? Where do we go from here with these increasingly capable systems?
Well, while routine is clearly incredibly effective, the paper does point out a current limitation. It still relies quite a bit on having experts provide those initial drafts and on doing that instruction fine-tuning. That human element, while powerful now, can potentially limit how well the system generalizes when you introduce totally new tools or brand new workflows. There's still room for more agent autonomy.
So what are the next steps in the research?
Future work mentioned includes things like incorporating reinforcement learning. The idea is to improve the planning model's ability to generate good routines more autonomously without needing that human draft, and also to enhance the execution model's ability to invoke tools even more effectively. Combining those could offer even more flexibility, less manual setup. There's also really exciting potential for multi-agent frameworks. Imagine a high-level agent coordinating several specialized agents, each using its own structured routines. That could break down incredibly complex enterprise workflows into manageable chunks, reducing the length and complexity of any single plan.
Interesting. Multi-agent coordination using routines.
Yeah. But ultimately, the routine mechanism, as it stands now, provides a really practical, accessible way to build these stable, reliable agent workflows. It significantly boosts the adaptability of AI agents for these complex business scenarios. It moves us much closer to that vision of AI for process, where AI isn't just helping out, but actually driving and optimizing complex operations.
That was an incredible deep dive into the routine framework. It's genuinely fascinating to see how adding this layer of structured planning can unlock so much potential. It really feels like a major step towards making AI agents robust and truly reliable for complex enterprise tasks, moving from cool experiments to dependable business tools. Hit like and subscribe if you like the content. See you next time.